The first equation, Einstein's energy mass relation, that is E equal to mc squared. This equation states that energy and mass are equivalent. It is a simple equation only involving the multiplication of C. This equation is useful in particle and nuclear physics. Mass of a body is a measure of its energy content. Second law of motion, that is F is equal to ma. The force described as a push or pull is the source of acceleration in a moving particle. Newton defined the force in the year 1686. This equation is used to know how powerful an engine has to be in order to pull a car and how much thrust is required to lift a rocket. Third equation, the Schrodinger's equation. Newton formulated the foundations of classical mechanics, and Schrodinger's equation formulated by Erwin Schrödinger in the year 1926 is the quantum analog of Newton's second law. This equation incorporates the two key concepts of quantum mechanics, that is the wave function as well as the operators. Operators means anything with a hat over it. The operator used here is a Hamiltonian and extracts the energy. This is a theory which is one of the pillars of our modern electronic technology. The fourth one, that is Maxwell's equations. Maxwell's laws are a collection of four equations that were brought together and used to formulate a unified description of electricity and magnetism by the Scottish physicist James Clerk Maxwell in the year 1862. The first equation relates the flow of electric field, that is E, to the charge density, that is rho. And the second law states that magnetic field have no monopoles. The last two equations tells that a changing magnetic field will create an electric field and vice versa. Therefore, these equations led to the understanding of electricity, which laid the foundations for the digital revolution and the computer you are using. Next one, second law of thermodynamics. This law states that the entropy represented by S of a universe always increases. Entropy can be interpreted as a measure of disorder. Therefore, the law can be stated as the disorder of the universe increasing. An alternative view of this law is heat only flows from hot objects to the cold objects. Next equation, the wave equation. The wave equation is a second order partial differentiation equation that describes the propagation of waves. It relates the change of propagation of the wave in time to the change of propagation in space and a factor of warp speed squared. So it is elegant and has been applied to the things such as sound waves, waves in fluids, light waves, quantum mechanics, and general relativity. Next equation, the Einstein's field equation. This equation gives the fundamental reason for gravity, mass curving space-time. That means a four-dimensional combination of 3D space and time. Next equation, Heisenberg's uncertainty principle. This equation was given by Werner Heisenberg in the year 1927. This equation states that more certain you are about a particle's momentum, that is p, the less certain you are about the particle's position x. Therefore, the momentum and position can never both be known exactly. Next equation, Planck's equation. This equation states that electromagnetic energy can only be emitted or absorbed in a specific amounts. Electromagnetic radiation not being a continuous wave, but it is actually many photons. We call it as a packets of light. Therefore, the energy of a photon, that is E, is proportional to the frequency. The last equation, Dirac equation. The symmetry is the key word of physics, and Dirac used it perfectly in the year 1926. He developed an equation to explain the spin number as a consequence of the union of quantum mechanics and special theory of relativity. This equation is used to predict the existence of